In the previous section, we used a single precision floating point data type in FPGA VIs. By the end of this module, you will be able to describe 3 types of FPGA math and analysis VIs. In this section, we'll be describing performing FPGA math and analysis with some of the functions that are provided on this palette. So if we take a look on the right, we have a screenshot of that palette, and notice there's a lot of configurable and pre-built functions available for you. So there's stuff for mathematics, measurements, there's control things. For example, there's a PID VI in there. There's filtering, signal processing, and high throughput math, and there's a lot more as well. So feel free to browse through this palette and see what's available. So in the FPGA math and analysis palette, there's going to be 3 types of nodes that I just want to go over real quick. So one is a primitive, and we're going to talk about non-configurable express VIs and also configurable express VIs after this. So a primitive, you can think of this as just a normal function. So notice that it's got a yellow background. So you're not going to be able to double click into it and look at a block diagram for it or anything. It's just a low-level function. And the primitive that we see here is essentially a feedback node, or it can also be called a Z-transform delay node. Now let's talk about a non-configurable express VI. So if you take a look at the linear interpolation VI that's there on the left, it looks like a normal VI, but if you were to try to double click it, you wouldn't see a block diagram, and you also wouldn't see a configuration window. So if you see that behavior, that's a clue that it's a non-configurable express VI. So why is it an express VI behind the scenes? Well, the express functionality that it's bringing is, you notice that it's dealing with fixed point inputs and fixed point outputs, right? So what it's actually doing is it's taking those inputs, and behind the scenes, it's adjusting the fixed point configuration of the output to accommodate that, kind of like we saw with the arithmetic functions earlier. Okay, so if you wanted to take that VI and for some reason you wanted to customize it and add your own logic, you could. And the way that you would do that is you could right-click it and then select Convert to Sub-VI. And then it would look something like we see on that yellow node. And it now looks more like an express VI. At that point, you can double-click it and look at the logic, and you can try to adjust it. Just know that if you do this and you save your own custom VI, then you lose that express capability of being able to adjust for the function to automatically adjust the output data type based on the input data type. So for the most part, you probably won't be making your custom VI from this. You'll probably just use these non-configurable express VIs as is, and know that the output data type is already going to be adjusted based on the input data types. And we also have the familiar configurable express VIs. So these are just going to be the VIs that you see on the palette that have that blue border or a purple border. So if you double click these, it's going to launch a GUI for you to graphically set settings and things like that. So these are more like the familiar express VIs that you've worked with before. Now you can describe 3 types of FPGA math and analysis VIs. Next, we will describe the effect of VI execution modes, throughput, and latency on FPGA math and analysis VIs.